Now, this question says the length of a rectangle increases by 25%. By what percentage should the breadth be changed to maintain the same area? One thing is very clear, the breadth has to be decreased. Why? If the length increases, area increases. But we have to maintain the same area, so breadth should be reduced. Alright. Now there are two ways to do this. One is the direct successive change method. Here, change in length is A, that is plus 25%. Change in breadth B, that is B. We don't know how much is it, right? So let it be just B. And the net change in area is given as 0. Why 0? Because it's the same area. So no change. No change means 0% change in the area. Alright. How do we use this? We know that the net change has to be calculated as A plus B plus A into B by 100. That has to be 0. Initially, don't worry about B, because if it is decreased, it will come out to be negative. If it is increased, it will come out to be positive. Though we already know in this case, I'm saying in any other case, suppose if you are not able to make out whether it is positive or negative, don't worry about it. Just use the formula, you'll automatically get the required answer. Let's see how. A is 25 plus B plus A is 25 into B by 100. This is equal to 0. 25 cancels 100 4 times. This 25 goes to the other side, so it becomes minus 25. And on this side, we have B plus B by 4. Now, B plus B by 4 is actually 5B by 4 equal to minus 25. Now, 5 cancels 25 5 times. 5 into 4 is 20. So, this gives us B equal to minus 20. As you see, directly finally we get B as a negative value. So, what does it mean? Change in breadth required is equal to minus 20%. And how do we say? It is 20% decrease in breadth that is required. Alright. So this was a good question. Just understand that. Now let's look at another method of this. What will be the other method? Other method is the conventional method where we assume some original value. If I assume original area to be 100, the final area will also be 100. Why? Because we have to maintain the same area. But in between there will be two changes. One change due to change in length and one change due to change in breadth. The change in length is given 25%. So the area will also change by 25%. Right? This is due to change in length. Now 25% of 100 will be 25. So if it gets added, it becomes 125. Now whatever change happens from here to here, it is due to change in breadth. Right? So this is what we have to calculate. So this becomes our initial value, this final value. So the percentage change for this particular segment will be equal to final minus initial upon initial into 100. So this becomes 25 upon 125 into 100. Now 25 upon 125 is 5 times. It is minus sign. And 5 cancels 100 20 times. So it is minus 20%. So as we have already discussed, minus means decrease. So it is breadth to be decreased. Breadth should be decreased by 20%. Alright. So this was a good situation. Okay. Now let's look at this question. It says the price of tickets at a theater increases by 60%. And we are assuming that all the tickets are of the same price. So all of them increase by 60%. And the number of people reduces by 20%. We are assuming 100% occupancy initially. So later on, like I said, whatever it was, it reduces by 20%. Find a net percentage change in collection. What does it mean? How do we do this? Before going ahead, let me put it this way first. We did it for area, that is L into B. Right? Look at this very, very carefully. It's very important. If we know the changes in these components, we could find the net change in area. Right? If you know the percentage change in length, if you know the percentage change in breadth, we could find the net change in area as successive change. Alright. This logic can be applied to any situation wherever there is a value P, which is a product of other quantities. So if there are two quantities Q and R, if you know the change in Q as A%, and if you know the change in R as B%, if you know these changes, if you know the change in Q, if you know the change in R, then change in P, net change in P can be directly calculated as A plus B plus A into B by 100, this much percentage, right? So this is one very interesting thing. Not only for area, it is always applicable for all the situations wherever there is a quantity which can be presented as a product of two other quantities. Alright. Now in this case also, how would you calculate the total collection? What do you mean by collection? The total amount of money collected at the end of the day. So total collection is equal to the number of people into the price. Right? It's the same situation. Collection is a product of number of people and the price. The price has increased by 60%. So change in P is given as plus 60%. And change in number of people reduces by 20%. So the change in N is given as minus 20%. So the net percentage change in collection is given as, we can simply apply the formula A plus B plus AB by 100. A is minus 20, B is plus 60. So minus 20 plus 60 plus minus 20 into 60 divided by 100. 0, 0, 0, 0. So this becomes 40 minus 12, that is plus 28. Right? So that means the collection increases by, we say that 28% increase in collection. Right? 28% increase in collection. Okay? So wherever there is a multiplication and you know the percentage change in the components, you can apply the successive change formula to find the percentage change in this. And reverse also. Suppose this was given, you could also calculate B. Okay? And for any other situation. Alright, let's take one more situation in this. Now, this question is again a tricky one. The price of oil increases by 20%. By what percentage should a family decrease its consumption of oil to maintain expenditure of oil? Right? Let's see. How do you calculate the expenditure on anything? The expenditure will be equal to the quantity into the price. The quantity into the price. Right? Here, we have to maintain the same expenditure. So change in expenditure is 0%. It's already given. Change in expenditure is 0%. The change in price is given as 20% increase, so plus 20. And we have to find the decrease in consumption. Whether it is increase, decrease, it will automatically come. Let's assume this Q is the quantity. Quantity means consumption. Okay. Let's assume the change in quantity is X%. Whether it is increase, decrease, it will automatically come. What we need to memorize that the change in expenditure has to be the successive change of changes in these two items because it is a product. We have already seen and explained this earlier also. So the change in expenditure, which is 0, is equal to the successive change of X and 20. Now how would you write successive change of X plus 20? You apply the formula A plus B plus AB by 100. So X plus 20 plus X into 20 upon 100. Right? 20 cancels 100 5 times. This 20 comes to this side, becomes minus 20 equal to X plus X by 5, which is 6X by 5. Alright. So X is equal to minus 20 into 5 upon 6, that is minus 100 upon 6, which is minus 50 upon 3, that is minus 16.2 by 3% or minus 16.66%. So it has automatically come negative. That means that the consumption has to be reduced. Right? So we can say that consumption should be decreased by 16.2 by 3% or 16.66%. That is the answer of that question. Alright. So we can directly apply this formula whenever there is a situation where one quantity is the product of the other quantities. Alright. Obviously, there is another way of doing that question. I'll just show you here. Suppose we assume the original expenditure on oil to be 100. Let's start from here. Original expenditure to be 100 rupees, right? Now, if I maintain the consumption, the price increases by 20%. So the total expenditure will increase by 20%. So it becomes 120. But I have to bring it down to 100 again. Why? Because the final expenditure has to be the same as original expenditure. So this 120 has to be reduced to 100. By how much will it reduce? 20 rupees. What is this 20 as a percentage of 120? That will be the percentage change in consumption. So percentage change in consumption is equal to final minus initial, that is 100 minus 120 divided by 120 into 100. So it is 20 by 120 into 100, that is 1 by 6 into 100, which is 16.2 by 3% or 16.68%, and it is decrease, percentage decrease in consumption. We can see it is from 120 to 100, it is a decrease. So this was the other way of doing the same question. Okay. Now this question says the radius of a circle increases by 10%. Find net percentage change in the area of circle, right? We know that the area of circle is equal to pi r square. Here pi is constant, pi into r into r. R square is r into r. If this r changes, this also must change. Here also this is a situation of multiplication. Area is a multiplication of two quantities. The change in r is given as 10%. The change in this r is also given as 10%. Oh, so that means we can still apply the successive chain method. Change in area will be equal to, straight away, a plus b plus ab by 100. So 10 plus 10 plus 10 into 10 by 100. Alright. So this gives us 10 plus 10, 20 plus 1, 21%. So the area increases by 21%. Okay. So this is one very beautiful situation. Wherever there is a product, change in the final quantity can be calculated as a successive change in the component quantities. Alright. Let's take one more question. Now this question says the length, breadth and height of a cuboid increase by 10%, 20% and 25% respectively, right? So the length increases by 10%, breadth increases by 20% and height increases by 25%. Find net percentage change in volume. We know that the volume is equal to length into breadth into height. Alright, so what we will do is, it's given that the change in length is plus 10%. The change in breadth is plus 20%. The change in height is plus 25%. So what we need to do is, now for three changes we don't have a direct formula. So what we will do is, to find the net change in volume, because we have the formula only for two changes, what we will do is, first we calculate the net change of these two, let's say it is x%, and then we find the net change of x and 25. So here it will be x plus 25 plus x into 25 by 100, right? We can combine two of them at a time. So for this, to calculate this, we need to calculate the value of x. So from here you can see that x will be equal to 10 plus 20 plus 10 into 20 by 100. Now this is 30 plus 0, 0, 0, 0 cancel 2. So it is 30 plus 2, which is 32%. Now we put x 32 here, so it becomes 32 plus 25 plus 32 into 25 by 100. Now 25 cancels 100 4 times, 4 cancels 32 8 times, 32 plus 8 is 40, 40 plus 25 is 65. So 65% is the net change in volume. It is 65% increase, right? So even for three changes we can apply successive changes, just that first you have to combine two of them and then the resultant of two and the third one you have to combine again. Alright, so this is how there are some tricky questions that can be asked in percentage chapter. Okay, so this is where we'll close this chapter. We'll close this exercise. You go through the theory video again, go through the questions that we have solved here, solve them, try to solve them again on your own. Also solve the questions given in the book and the class exercise. Get back to us if you have any problem. Thank you so much. God bless you. Take care.